All right, so we are in Section 3, Week 3, Video 2, the Friday. So we will have a lecture today, a lecture on Tuesday, and then quiz on Friday the 12th, and then we will just move into the driving game after that. So last lecture, it was pretty heavy on the enemy turret, on the enemy turret script, and covering the animator and animations for both the turret and hoverbot. And enemy turret, we got into some good, like, how are we handling like the AI states, when are we attacking or not attacking. And that led us to, like, they're like setting a lot of triggers and rules on the animator, and that led us into looking into the animators and their parameters and the different layers. Remember, overrides and additive layers. All right, so let's take a look at EnemyMobile, which hopefully has some overlap to enemy turret, and then we'll somehow have to figure out the nav mesh, and if it turns into a black hole, I'll switch over to I'll switch over to the weapon controller, and let's take a look at nav mesh on Tuesday. But let's take a look at the EnemyMobile anyway. So we have our enum, right? So let's see, required component, enemy controller, that's the same as enemy turret. So we have our different AI states represented as an enum. Patrol, follow, attack. So we have some new ones here. We don't just have idle and attack. We actually are patrolling. That's like your idle, follow, and attack. So we have an animator, a bunch of VFX arrays. So it looks very similar right off the bat. And we do have some more of these constant strings here, but we have different AI states to move between. So let's see, on start, we're going out to the enemy controller, and I think enemy turret was only interested in like two. Yeah, it was just interested on detect and on loss, which is kind of really ultimately coming from that detection module. But mobile is interested on attack, detect. So we have detected and lost target. So these are definitely coming from detection module. On attack and on damage. So on damaged, notice they're all listening to the enemy controller, but this is ultimately coming from like the damageable and health, like the damageable script and the health script are talking a lot. So that's over there. And on attack, we'll take a look. Maybe that's coming. That's probably a mixture of like the the detection module, and then there's probably a call going off to like the weapon controller. Like, remember that try attack, and it's like probably ultimately the weapon controller tells you if you can actually attack at that moment. But anyway, so we're listening to a bunch of our enemy controller events, our Unity actions, and set path destination to closest node. I'm going to take a look at that real quick over an enemy controller, because this is starting to get into patrolling with the nav mesh and stuff, and let's just see what's happening here. So set path destination to closest node. Okay, very descriptive. Is path valid? Okay, so return patrol path and patrol path nodes count. So do we have a list of path nodes? Is it greater than 0? Okay, so we have some type of patrol path on our enemy controller. Public patrol path gets set. All right. How is this being set? Let's see who's who's dealing with patrol path. Wow, so there's a patrol path script. Interesting. Let me just see if it's being exposed out here somehow. So out here in EnemyController, let's see if patrol path is sticking out in any way. No. Oh, paths. I didn't notice this over here. Okay. So we do. Interesting. So enemies to assign. Oh, it's kind of a little weird. Anyway, so under paths over here, we have patrol. And here's the patrol path, and then there's some points. So this must be the 3 points that he moves between. This one, and this one. And it says like, and who's who is assigned to this patrol path, and it's this hoverbot here. And then we have the 3 nodes, the three transforms that are underneath here. So okay, cool. There is a patrol path. Let me just double check if it's the. This is kind of a weird. I didn't even notice that there was this other script kind of sitting out here. It's a little hidden. Let me move it over here. Let me move EnemyController here. All right. Let me just take a look at this control path here. So this changes things. I thought it was somehow the nav mesh was dealing with this, but they kind of set up their own patrol paths. Okay, so the list of enemies that are allowed to be on this patrol path. We want to grab their enemy controllers. A list of the transforms of the patrol paths. Okay. And for each enemy that's in this list, that it must have gotten manually assigned the inspector. Okay, that's ultimately where I wanted. So where the hell is this being assigned? All right. So this patrol path is public property, and the patrol path script actually goes out to each enemy that's been assigned to it and sets that property to this instance of the script. A little strange. Kind of a little convoluted to move around and understand that. Anyway, so that's what. So now I'd say this is happening. And okay, so is path valid? Do we have a patrol path assigned to us? And are the number of nodes greater than 0? So for this hoverbot, this would return back true. All right. And so the distance to patrol to path node. So loop through all the nodes. Okay, so find the closest node. Got it. So the patrol path that this enemy hoverbot is assigned to has 3 nodes. We're going to loop through each node, right? And we're going to get the distance to each node. So we're going to go to patrol path and call get distance to node. So there needs to be an origin and a destination. So the origin is the transform position on the enemy hoverbot. And then we pass in whichever node. I is referencing the index for each node. And so we jump over here. And we say if this index that comes in, if it's greater than 0 and if it's less than 0 or it's greater than equal to the size of the list, basically. Or if we look into the list and whatever that element is pointing to is null, then we return -1. It's like a value that we use to say, you know what, forget it. This isn't going to work for us. Something's wrong. Otherwise, go in and get that element and get its position. Remember, each element is pointing at a transform. So get its position, and then subtract this origin position that was passed in. So take one vector 3, subtract another one, and we'll get a vector 3 as the direction. And then you can just get the magnitude, the size. We only care about the size. What is the distance from where the current hoverbot is to this current path node? All right. So what we do is we loop through each node and we see, get the distances for each. And then we see who is the closest. So currently it's set to the first index 0, like the first node. But if whatever we just looked at, the distance is less than the get distance on the closest one. Oof, they're doing way more calculations than they need to. Repeat calculations, not good. Anyway, they loop through and they say they find the closest node to the enemy hoverbot. And then they say, okay, this node, this is the one that the enemy hoverbot will ultimately be assigned to. All right. So, got some draw. I'm just looking at the rest of the patrol path. So on start, go into your enemies that are assigned to you, take your patrol path property, assign it to this object, and then we have this public method to get a distance, this public method to get a position of each of whichever node you want, and then some debugging, just drawing. I didn't notice the because I always have the debug off. Okay, so here, this little triangle here, this is telling you, yeah, notice that I move something and then it updates. Okay, so they're just trying, when you click here, you get to see what the patrol path is going to be like. Cool. All right. So that was set path. So where ultimately I was up in EnemyMobile. Okay. So on start of EnemyMobile, go listen to all these events, and then go call this set path destination to closest node. So basically, you know, this is a hoverbot. You have a patrol path. Go figure out the closest node because we're going to start to move you toward it. Put them into a patrolling AI state. So get the audio source that's sitting on the enemy. Must be down toward the bottom. Yeah, here's the audio source. And it's hoverbot movement. Okay. And then play it. So get the component audio source, set the clip to movement sound, and play. So movement sound must be sitting up here. Damage, tick. No, it's not. Usually when it's a capital letter like that, it's usually a property. You know what? I'm on mobile. I was looking at controller. Here we go. Movement sound. None. Interesting. Maybe that gets assigned at runtime, but it's empty right now. All right. So in the update the AI transition, update the current AI state, and then do some more lines of code here. So update the AI state transition. So let's do a nice switch on an enum here. Follow or attack. We're not doing any of these right now, so I'm going to ignore it because we're in patrol and there isn't a patrol case. So when that happens, we just don't execute anything. All right. Update current AI state. So patrol. Update the path destination and set the nav destination. And that's it. All right. So we go to enemy controller. And we're going to update the path destination. So we've already done this if check. We know that the path is valid. So if your current position, subtract get destination on path. Okay. Get destination on path. If path is valid, yes. Return patrol path dot get position of path node. Pass in the index of the closest one because we've already figured that out. So this is just returning the global position of the path node that we're trying to get to. Okay. So take your current position, subtract where we're trying to get to. Basically, it's like how far, and then take the magnitude of that. It's like how far are we to our destination? And if that is less than or equal to path reaching radius, yeah, I thought it was sorry, I thought it was highlighted up here. Here, path reaching radius. Why don't you show me that? So I'm just doing a peek. It just like shows you a temporary view. So it's up here at the top. Public float path reaching, say 2 meters. Okay, that's great. So if wherever we are, subtract where we're trying to get to, you can take that magnitude, the distance to where we're trying to get to. If that ever gets less than 2 meters, then they're basically like, okay, you've reached the node. It's time for you to go swap out to another node. So then we take the index of the node list that we're currently set to, and are we in reverse order or not? Let's just say it defaults to false, so we're not doing some funky reverse order. No. So all we do is we add 1. So for at 0, we go to 1, right? And then if this node index is less than 0, okay, so if we're going in reverse order and we drop it down less than 0, then we just like move it to the end. If we're going down the list from length of list -1 down to 0 and we pass 0, then we have to set it back to add the count back. It'll get back to n-1. If the node index gets greater than or equal to the size of our list, then we're in issues, right? Because the last index is n-1. So then what we do is we subtract. So if we ever get to count, all we do is subtract count, and then we'll get back to 0. So it is what it is for this logic. But basically, we keep going up. We go 0. In this case, there's a list of 3. So we go 0, 1, 2. And then we get to 3, and you're like, that's invalid. Drop back to 0. So we just keep repeating 0, 1, 2, 0, 1, 2. That's how the enemy keeps moving around in a cycle in the path. All right. So if we go back to EnemyMobile, that was update path destination. Basically, we keep going to the node until we get too close to it, and then we set looking at the next node. And then set nav destination to whatever node we're trying to get to. All right. So set nav destination. So set nav destination. Oh, interesting. This is the first time I'm actually seeing like the nav mesh agent. So if there's a nav mesh agent, go call set destination, put the destination into the nav mesh agent. Cool. So what's this thing about? So public nav mesh agent. It's not showing. Okay. So, private set. All right. Let's see who's looking at it. Nav mesh agent equals get component net. Okay. So this must be down in awake or something. Yeah, start. So go get the nav mesh agent. That's a component on our game object. Sounds great. And then here, if we update some speed and stuff. So ultimately, I'm not going to call it just yet, but it looks like nav mesh agent is. Let me keep reading. So we're going to our nav mesh agent and we're setting the destination. And I think that from our code perspective, that might be it. Nav mesh agent might be like saying, okay, my nav mesh agent is saying I should be heading toward whatever one of these node points, and nav mesh agent might be taking over the responsibility at that point. Steering, obstacle avoidance, pathfinding. Yeah, I mean that might be it. They're actually not moving. The code isn't. The developer code isn't moving the hoverbot, unless I stumble upon that later on. But it might be nav mesh agent doing it. Let's keep looking. So in the update, I just covered this. I just covered this. Update current AI state. All right. So float move speed. Go get the nav mesh agent. Get the velocity. How fast it's currently moving. So velocity is a vector 3. And velocity is telling you not only the speed, but velocity tells you the direction that you're moving as well. Like how much are you currently moving and in what direction. So it's a velocity 3. So that they're taking the magnitude of it. Like just give me, that's just the speed. When you remove the essence of the direction from velocity, what you're left with, the magnitude of velocity, is what we call speed. Like there's no direction associated speed. I'm just doing 60 miles per hour or whatever. Okay, so we're getting move speed. Now it's going into the animator and it's setting a float move speed. And so this must be, we looked at the animator already, but this is what was setting off, like, should it be in idle or should it be in patrolling or what have you, locomoted or alert. Because if you look at these transitions, move speed needs to be greater than 0.05. All right, so we're setting the animator. And then change the pitch of the movement speed. Okay, so the source of the sound coming from the robot. So based on how fast it is, the pitch is like the frequency. It makes sounds higher pitch. It gets like a higher squeal, whatever noise is coming off the robot. So you can change the audio pitch. So pitch is just a float. So we use mathf.lerp. And we're going to lerp from our min to our max of whatever this pitch distortion movement speed is. And then we're going to figure out where are we along this A to B. We're going to take the move speed divided by speed of the nav mesh agent, which kind of sounds stupid to me because they just took the magnitude of the velocity. So to me, the nav mesh agent speed, the maximum movement speed. Okay, this is not speed, this is max speed. It's just the variable is named poorly. So take our current move speed divided by max move speed. That makes sense. And that shows you from your min to max pitch, where should we be? All right. So that seems to be everything. We have this on attack, on detect, but these are being called by other. Basically on attack, we're setting an animator, and undetected, we're switching some AI states and setting the animator. These are all very similar to enemy turret that I covered last class. But the big thing that's interesting to note is that we're actually not even messing around with having to manually move the enemy hover bot between the node positions. So the where is it here? Set nav destination over in the enemy controller. This is going into the nav mesh agent. It's kind of goofy that they don't have an else. If you don't have a nav mesh agent, then you should be kind of just doing your move manually, like go get me the transform. And there's like a function like move at or something, move towards, and you could just pass it in the node position and just say how much you want to move towards it, and it'll figure out the math for you. But this is just saying, hey, there's a nav mesh, and that's it, nav mesh agent, and I'm just going to have it do my movement for me. That's cool. And that's this thing here. So once you bake out your level, you make your nav mesh, and you put a nav mesh agent on your. You can just say, hey, go to, you do your settings here. You just say go set destination, and it'll just move towards it. It's pretty useful. All right, so that was EnemyMobile. All right, so I should probably look at update enemy. So that was just so if you look back in this update here, let's just look at the state transition again. So if we're in follow or attack, so how does follow get? Let me just see where we switch from. Okay, undetected target, right? So this we're listening, but ultimately this is listening to detection target, detection module. So detection module fires off an event when it detects a target, and only the enemy controller is listening to that, and we're listening to the enemy controller, and this will get called, and we're saying, hey, if we're just patrolling around and we just got notified that we detected a target, then we're going to go into the follow state. All right. And we're going to play some VFXs, whichever on-detect VFXs we have. We'll have some sound effects and set the animator here. Set the bool, this one, to true. And what happens then is we go back in our update loop. And then the next frame happens, and we go into our update loop, and then it says, oh, we're in follow now. Okay. So if the enemy controller, is seeing the target, so this is coming from detection module. Remember, we're checking, like, in that current frame, are we still seeing the target? So this is a bool, true or false. And is the target in attack range? So are we currently seeing the target? He's not like through a wall at current time. And the target is within the attack range. All this is coming from detection module and being sourced out to enemy controller. Then we're going to move into the attack state. And we're actually going to start to move. No, this was already set. When we went to follow, this was... we're already following the person. But anyway, we're still setting back. We're still going to confirm that we're following. And if this doesn't true, we're still just following. We're still chasing after the player. Nothing's changed. We just keep looping, keep following. And if we lost them, we go into patrol and just go back to patrolling. But if we ever get close enough where we're in attack range, then we go into attack. And so here's the next step. So when we're in follow, just keep following the known detected. Here we go. Set nav mesh destination. Keep following. Something new here. Like, they shouldn't even had to have this line here. Just keep following the player. Orient yourself towards your player. Orient your weapon towards the player. Just a lot of rotation tweaks. Just always be oriented toward the player when you're following. But eventually we get close enough and we have a direct line of sight, we're going to go into attack. So if we ever get into attack range, then if the Vector3 distance from the enemy controller known detected target, that target, the player, its position, to our detection module on the enemy mobile, if this is greater than or equal to attack stop distance ratio times the attack range, then set nav destination back, keep going towards the player. Else set it. Okay, so basically this means we've got like two ranges of attack. So it means like there's a certain distance range where the hoverbot is just following the player, but they're not close enough to attack range. And then it looks like they split up attack range into kind of two ranges. There's the far attack range, where you can still fire your laser weapon, but you're still kind of far away from the enemy, which is the player. So you should keep moving toward your target. You should keep moving toward the player. So basically you're firing and keep moving. But if you ever get within this like attack stop distance ratio times the attack range, if the enemy ever gets within that, they're just going to stand still. They're going to set their nav destination to themselves. Just stand still and keep firing. It's kind of stupid logic. Well, yeah, it is stupid logic. I hate when enemies just stand still and they're firing at you. Like, you should at least like pick like a random location within a few meters and kind of do like a zigzaggy pattern or something. Like, make it kind of hard for the player to shoot at you. Sure, if you want to keep moving towards the player to like close your distance to increase your chances that your shots will hit, okay. But if you're really close to the player, don't just stand there. Like, do some type of random movement to really make it hard for the player to hit you. In any case, after figuring that out, we should try. Okay, here we go. Enemy controller. Orient towards your target and then try to attack your target. And then done. And so we keep doing that. And eventually, if we're in attack and the target's not in attack range, we go back to follow. And if we ever somehow lose sight of the lost target, if we're following or attacking and we lost the target, just go back to patrol. All right. So let's look at these two. Orient towards is probably not that interesting. It's probably more like rotating your pass in your look direction, which is like who you're looking towards, which is the player. And then they're doing that project on plane, which I've covered before. Like, let's just look at them. Let's ignore the up and down, the Y. And then we have to deal with quaternions because these are 3D rotations. Do quaternion look at and pass in the vector 3. We don't need to worry about the math of how to create that quaternion and set your rotation to that. Then it looks like, don't even just do an instant pop. It looks like we're going to keep rotating towards them a little bit at a time. For each frame, where are we now? Where are we trying to get to? And then take the little delta time, the little section of time between the update frames times the orientation speed. So like over a certain amount, you'll keep kind of slowly turning, keep turning towards the player until you're just like looking at the player instead of like a quick pop. But I think the more interesting one will probably be like, let's do try and attack, and then this will naturally lead us into the weapon controller. And so we're going to be moving off of these enemy controllers and nav mesh stuff, and we're going to be moving into weapon controller now. All right. So if the player just died, basically, just stop firing, even though you have them on target. So orient your weapon towards them, just some rotational stuff. So go through all your weapons and orient each one toward the player. Sure. All right. So if the last time that the weapon was swapped, plus the delay after a weapon swap is greater than or equal to the current time, then return false. You can't fire. Meaning you swapped your weapon too recently, and the delay, you need to wait a little bit. You're still in that delay time before you're ready to fire. And then otherwise, shoot the weapon. So get the current weapon, handle shot inputs, or shoot inputs, and this is going to return a true false, right? So if this returns a true and on attack is not null, okay. So on attack is an unity action. So if someone's listening to the on attack action on this enemy controller, like probably EnemyMobile, and we just tried to fire and we did fire, then awesome. Let's invoke the on attack. Whoever's listening to on attack. So I think EnemyMobile. Yeah. So all this is doing is it's calling an animation trigger and it's just playing an animation. And if swap to next weapon, and we have more than one weapon in our weapon list, then increment the index. This modulus operator is like, this just does that kind of cycling through the list. But anyway, pass in the index and pass into set current weapon, and then return did fire true or false. I went over this kind of earlier in the semester. Basically, if it's a list size of 3, and you go 0 mod 3, 1 mod 3, 2 mod 3, you'll get 0, 1, 2 back. But if you get 3 mod 3, you'll get a 0 back. It's like a way to always be cycling in the numbers less than the size of the list. So I got to go up here. Now we got to get introduced to the weapon controller. But before we do that, let me just set current weapon, because this happens to be on the enemy controller. So this int comes in, it sets this field. Current weapon. So we have a list of weapons somehow. This is probably coming at the in the start or awake, and it's probably checking the weapons controller. But we have a list of weapons that are available for us, and then if we choose to, some number was passed in, and then we grab that weapon, or that's what we say we're using, and then there's like a rundown, like we have to say, oh, we just swapped, so we have to put that number in. Cool. So that's a natural transition. We went through NavMesh Agent, we went through EnemyMobile, and we had to return back to EnemyController for quite a few other interactions there with these script objects. And now let's go down here, and here's our weapon controller. All right. So it looks like we just have laser eyes, and it looks like we just have one weapon, and there's like the root of the weapon and the muzzle. So we're like the tip that we're firing from, and where's like the root of the weapon. So let's take a look at what's happening with this weapon controller. And the enemy weapons are probably going to be simpler than the player weapons. So it's interesting that we're coming in and looking at this shared weapon controller between the enemy players, but we're coming in from the enemy side to take a look at it. 1 second, I'm just checking on the time. Okay. So, weapon controller, let's take a look at it out here. Okay, so information, weapon icon, the root, the muzzle, the shot parameters, shot type, the projectile that's going to be coming out of it. So now we got a prefab we're going to have to look at. Delayed between shots, recoil, ammo parameters, has automatic reload, clip size, charging weapon, looks like it's not, and audio and visual parts of it. All right. So, Enem, weapon shot type. All right. So it could be a manual, an automatic, or a charge weapon. Those are all the types of weapons we got. And we have system serializable. So we have a struct here. You remember a class and a struct? The struct is like a simpler version of a class. Just doesn't have methods. It's just a whole bunch of fields, properties. And it's really useful to like when an idea is more complex than one piece of data. So here we're talking about crosshair data, which involves the sprite, the size, and the color. Okay. And down here, the start of our class. So notice this was all defined outside of our class. So it's just in this namespace, uni.firstpersonshoot.game, but it's not within the .weapon controller namespace. Okay, so we require an audio source. All right, was there an audio source? Yeah, there is. And here's all of this properties that was exposed out in the inspector. And there's a lot of them. I'm just going to move through them a little slowly just so you can recognize that all these properties are actually what you were seeing No, not these here, because these have the private sets, but you get it. Okay, so here we have some more properties that are like little shorthand methods defined. So get ammo, get carried physical bullets, so on. Reloading. Then we got a queue of rigid bodies. So that's interesting. You get to talk about stacks and queues. So we've talked about arrays and lists. And notice that this queue is similar to a list in that it's generic and you have to specify the type. We talked about dictionaries. In a bit, well, I guess we're going to have to cover stacks and queues, which are basically just lists, but with some special properties. Awake. All right, so whatever max ammo is, that's what our current ammo amount is, our member or field. Carried physical bullets equals has physical bullets. If this is true, it's the clip size gets set to this. If it's false, it's 0. So does this gun actually have need physical bullets or not? And this was a laser. Let me just peek at the definition. False. And let me just make sure they didn't has physical bullets. False. Okay. So it's like a laser weapon. It doesn't actually have like physical bullets. Sure. Class muzzle position, audio source. Should it make a continuous shot sound or not? So if it has physical bullets, we can ignore that. Well, you can instantiate shell casings. Interesting. Okay, don't have physical bullets. So we have a private method, shoot a shell. It's probably part of like this. Yeah, it's part of this physical ammo pool. Pooling is a good concept. Let's see if we can get under there, because now we can talk about queues. Let's see. Play SFX, reload. Interesting, no one's calling it. No one's referencing it. It's like a dead function. Start load and start reload animation. Okay, here we go. Here's we got an update method, update ammo, update charge, update continuous shoot sound, show the weapon, use ammo. Okay, here's handle shot inputs. That's good to know about. Try shoot, try begin charge, try release charge, handle shoot. There's a lot going on here. Get shot direction. I guess because it can handle all these different types of weapons. Let's go back up and look at update real quick. So this is running all the time. Update ammo, update charge, update continuous shoot sound. If time.delta time is greater than 0, which it would always be except for the first frame. So I don't know how to do that check. But muzzle world velocity. So how much? Okay, I guess for the first frame this doesn't make sense because you haven't moved yet. But what was your position? Yeah, it's your last position. But there's no last position on the first frame. All right. So as you're walking around, there's a transform just for the weapon muzzle, and it's just trying to figure out what the velocity is if it's moving around. Sure. So update ammo. If automatic reload and last time since shot plus the reload delay is less than the current time, and current ammo is less than max ammo, and you're not charging, it's quite a lengthy logical scenario. But reload weapon over time. All right. So if you're missing a few bullets, oh sorry, I just saw that now. Is that built in, or did the developer make a queue class? So queue is built in. They didn't make a queue class. So if I hover over it, notice how it says system.collections.generic.queue. And if I go all the way up here, notice that this is highlighted like it's being used. Queues are another very standard computer science data collection. They're basically just I don't know if I'm going to liken them more to an array or to a list, but I'm going to liken them more to a list. But queues and stacks are used a lot, and you can actually just kind of build logic along with a list and make them function like a queue and a stack. But a stack should sound a little bit familiar to you, as in like Stack Overflow, and you actually have a stack of functions that are your function stack, like which function's calling what function, like nested functions at a certain time. But let's see which image looks good. They all actually look pretty good. So for last in, first out, LIFO. So stack. So think of them. I mean, you can vision them top to bottom or left to right. But when a stack starts growing and an element comes in, it comes in at the top. And when you need to pull one out and process it, it's that last one that came in is the first one out. So think of it like a stack of papers on your desk. You keep putting papers on top of your desk as like work is coming in, and you need to like do the work. You need to like get the piece of paper and do whatever it says, and you just kind of grab at the top. So what's at the top of your stack was the last element that just came in. So as there's enough time to do work, you have enough processing power, and there's something on the stack that needs work done, you're just gonna pop it. You're gonna take that element and remove it from the stack, but from the top. Last in, first out. So that means the one that's first in is just sitting there the longest. But it depends on how much you need to process. Stuff might be sitting there, you might be able to move through it. And then queues, first in, first out. So stuff starts piling up on top, but you're pulling from the bottom. So whoever came in first gets served first, FIFO. And here's what it looked like from left to right. So you start adding onto the right, and you start processing, pull off, and do what you need to do to it on the right. And queues, NQ. So this is called pushing onto a stack and popping off a stack. And it's all done on the top of it. And then the queue, N is NQ. You're placing onto the rear of the queue, and DQ, you're pulling off the front of the queue. And you can see that this is a linear or a sequential data collection, very similar to an array or a list. It's just it has some special features. It's basically when you're ready to process something and you want to remove it from the list and do something to it, it's just which side of it do you pull from. And so it really depends. Like when you're queuing up work, so queues are really popular in cloud computing. So you have everyone pinging this website, right? And all these requests to do some type of processing on the cloud, they all go into a queue called a message queue. And whenever that server has enough like empty time and it can like start work on the next piece of work, it'll dequeue from the queue. It'll pop off the next one so that whoever was waiting longest gets serviced first, which makes sense, right? So those are queues. And stacks are useful in other situations. So you'll see stacks as I can't think of the name of it right now. Was it function stack? I'm having like yeah, so which one looks the best? So when we're in like a function calling another function. Like, for example, when this update method, so here we're running every frame, right? And if we ever get to update, notice how this is a method call. So this update method gets put onto our function stack. And a function stack is like saying, oh boy, the CPU only has a certain amount of processing power, but the active application is like putting function requests based on whatever the user is doing on the stack because it can't like do everything all at once. So let's just say this update function, remember methods are just functions belonging to objects, gets passed onto the function stack because you got to process it for just this object, let's just say. And then we're in the middle of processing this update function. So it's sitting on the stack because we're in the middle of processing it. And then it's saying, oops, we have to process update ammo. So update ammo comes on the stack as well, right? So now we're building a stack of functions because we're like calling a function within a function with a function. And we have to move through the code here before we can exit this and move on to this, and then this, and then this. And then we can leave the update function. We can remove it from our stack. So we have update on the stack, and there's stuff even before update, but then we have update ammo, right? So we're processing update ammo. We're in the middle of doing all these lines of code. It might take a few cycles. Notice how there's no functions within here. And let's say we get to the end and we're done. Now we can pop update ammo off of our stack, of our function stack, because we're done. We don't need to, reserve it anymore on our stack because we don't need to process it anymore with our CPU. We can pop it. And so it was first in and last out because it was the last one on it was the last in, first out. Because it was the most recent function that got put on our stack, and we're moving through it, and then we're done. It needs to come off. So that's the why we have stacks, and they're useful in what we call function stacks. And this is also when you like watch your code. Like if you ever get to the point where you're putting in breakpoints in your code, and you're like trying to see debug stuff live while your app is running, while your game is running, and you can actually look through the function stack in Visual Studio. You could do a breakpoint and be like, oh, this function's calling this. Update is calling update ammo. And update ammo actually has like this wrong value here. And this is what's calling the bug. Anyway, function stacks. And queues, which are used quite often with like message queues on cloud computing. But yeah, that's all coming from C#. And we probably won't get to why are they using Q in here, like not till next Tuesday, because it looks like they're using the Q with these physical shells. So we have to go find a gun that's over on the player side that's using physical shells. Here, NQ, physical ammo, cool. So we'll return back to that. Update ammo. So something's happening here where it's like automatic reload. We don't have all our ammo. We can like slowly add ammo over time back to our pool. And this is somehow limiting it. I'm not going to go into charging and stuff. So let's just look at what we really need now with the weapon controller. So enemy controller. So somewhere there was that try to fire, try to attack, right? Orient the weapon. This was coming from EnemyMobile. Like we're close enough. We're in attack mode. We can attack. And it says, hey, enemy controller, try attack. And here's my enemy I'm trying to hit. And so this happens. Get the current weapon, which is the weapon controller, and handle shot inputs. False, true, false. All right. So false, true, oh, it's like mimicking player input. So is the input down? Is the input held? Is the input up? I think it was false, true. So the input is held right now. So if it's down or held, wants to shoot, that's true. One of these are true, yep. So switch on shot type. Manual, automatic. I don't know what this robot was using. He's got an automatic weapon. All right. So if it's automatic and the input is held, yes, which it is, then try shoot. So if you're holding down, it's an automatic weapon. If you just pressed it, then you can fire off a manual shot. All right. So then, okay, sure. Try shoot. We're good to go. All right. Try shoot. If how much ammo we currently have is great. Do we have at least one bullet loaded or something? Okay, that's great. Is the and the last time since shot, the last time that you shot plus delay between shots, is that less than the time of the that we're currently at in the app? That's kind of weird. So the last time that we shot plus oh right, so the delay, as long as the last time that we shot. So let's say we shot 3 seconds ago, and our delay is 2 seconds that we're allowed. We have to wait 2 seconds. And we're currently at like 6. Okay, I guess that works out. So basically, the last time you shot, and have you like waited long enough between shots, then we can handle a shot, and we can remove one of our ammo, and then we can return true. That try shot is true. And this returns whatever this returns, so this returns a true. Okay. And then what happens with a handle shot here? So, but how many bullets are in the shot final equals the shot type? Okay, so Jesus, I don't know why. So I hate when they just do if else when it gets a little complicated. So is the shot type equal to charge? If it is, then we do this. So we're not doing a charge right now, so it's just this bullets per shot, whatever this is. So I'm guessing it's just like 1. So this would be like a 1. Spawn all bullets with random direction. Okay, so we're doing a muzzle spread type thing. So bullets per shot. So let's just say there's 1. Okay. Get shot direction with spread muzzle direction. So this somehow adds like a little randomness. So say you're pointing directly at somebody, but they're gonna like add a little bit of like randomness based on your where your weapon muzzle is at, to just mix it up. You know, see if you're actually aiming correct, like you're gonna have an accurate shot or not. But what happens is we have instantiate the projectile prefab at the weapon muzzle position and orient it, rotate it, look direction toward the shot direction that we just calculated up here. And now we have a new projectile, and that projectile script is a script on the prefab, and we're going to call the shoot on it. So we're not going to be able to get to the projectile prefab now, but we will on Tuesday. But this will move, like all the logic now kind of moves over to the projectile. Like the gun has done its thing. We've calculated like our final shot to, direction with a little bit of randomness, and we've instantiated our projectile, and we've oriented it in that direction, and away it'll go, and we'll see what the projectile will do. And muzzle flash, nope, let's just say we don't have that. No physical bullets. So play some audio, save the time that we shot, set a trigger on a weapon animator, and is anyone listening to us? Does anyone care? Does anyone subscribe a method? Let's invoke it. Same for this one. But this handle shot was called by here. Okay, so the try shoots. Let's just say this is like returns true, right? All of this, I'm backtracking all the way, going back back through the function stack that I just talked about. And ultimately handle shot inputs what's called here on EnemyController. And this, let's just say that we did actually do it. So this is true. And then this will get called here. Just as anyone listening to us, let's update some times, or if we need to swap a weapon, and then return true here. And then who called this? EnemyMobile called it. So I'm going back and back through the stack. And ultimately it was done here because we were updating our current AI state and we were in attack and we did this try attack. So as for the enemy's perspective, we just keep looping and looping here. But if they did actually fire all the way back to weapon controller, where I'm going to pick up if on Tuesday is, where did we, okay, we instantiated a projectile prefab. So we could leave all of this and we're going to jump over to this projectile hoverbot, which has this projectile standard script. And there's probably got to be some other stuff. Maybe they're children. Let me shrink this stuff down. Okay, underneath here, here's the mesh. Let me press the F key. Where is it? That's this thing. Okay. Here's the material. Here's the mesh. Here's the tip of it. Oh, here's on the fat end. Okay, so it's moving like, it's moving this way, which is the big part's moving first. Okay. And anyway, at the top is this script is going to be a lot on Tuesday. Cool. So we went over EnemyMobile. We wrapped up Nav Mesh Agent. We had to go back into EnemyController. And then we spent the rest of our time here in WeaponController, which ultimately spawns a projectile prefab, which is where we'll pick up with on Tuesday. And, well, we got pretty far. Enemy hoverbot, nav mesh, weapon controller. We didn't look at the weapon prefabs. The actual, what's the prefab look like? So we have to look at weapon prefabs, projectile prefabs, and the projectile script. And then we'll be done on Tuesday. All right. That is all. I'm going to stop recording.